All right, hello guys. Welcome to this video. So in this video, I'm basically going to be walking you through how you can use a framework like DLT to achieve micro batch ingestion from a Kafka topic or group of Kafka topics into any destination that DLT supports, right? What I intend to do is walk you through how you can go from like the DLT Kafka verified source, right? Like the vanilla version of it that DLT has already implemented out of the box, and then like guide you through like some of the challenges with the vanilla implementation and how you can adjust it to build something that you can actually use in production, right? Um, the core idea or the motivation here is that many times, right, when you think about Kafka, you're thinking about like using the data in Kafka in real time. But then, especially for analytics use cases, you don't necessarily need to react or respond to Kafka data in real time. You just need to capture changes at the source, maybe as soon as they happen, but then you can choose the cadence at which you want to basically deal with that data or handle that data. And so in those kind of scenarios, a platform like DLT is superior and can basically help you do what you want to get done, right? Um, I have a repo here where I have set up like like a basic usage or like the basic pipeline, and then like gone from like that basic pipeline into something more advanced. I prepared like a technical design document to kind of like back up the reasons for wanting to even go in this particular direction with this project, right? And I'm basically just going to be walking you through all of that stuff, and then we're going to end it with like an actual CDC example, right? So the first thing I want you to know is I've created a data generator, and in that data generator, I've kind of like modeled an e-commerce domain where you have users, orders, products, payments, and returns, right? So basically, users can place orders. Orders will contain one to many products. Then an order will be paid for, so there will be payment records. And then in this particular design or in this domain, I also have an example where users can actually make returns, so they can return from whatever it is they order, right? But then essentially, before you even spin up like a DLT pipeline, or you run your DLT init Kafka, and then let's say your destination is DuckDB and you do DuckDB, before you do any of that stuff, data needs to exist in Kafka, right? And so what I've done is I've basically spun up like Red Panda to be like our UI, and then we're going to basically create topics here. We're going to populate those topics with data, and then we're going to use DLT to ingest that data and like write it into DuckDB for the example, right? So I have like a proper documentation for how the data generator works here. But then in the README, I'm kind of like walking you through my case for wanting to extend DLT Kafka. And so I'm going to go with the example here. So all we can do is we can start by generating data into a topic, a user topic, user data into a topic. And then for this example, we can start with 25 records, right? So when I run this, it's basically going to create the topic for me automatically, and then it's going to like populate that topic with 25 records. So if I refresh here, you can see we now have a topic called the user underscore JSON underscore topic. It has 25 records, and then you can see what this record looks like. So it's not a very basic like JSON structure, right? I mean, you have this array of addresses associated with a particular user. You have some information about the user, and then if the user is verified or not, and when that user was created and all that stuff. So I mean, it's a decent and like realistic complex schema, if you can think about it that way, right? So now that we have put 25 records here, what we can do is we can essentially run our baseline, right? So I have the baseline here, and what I've done is I just created this folder called dlt-kafka baseline, and then in this folder I ran my DLT init Kafka, and then my destination was DuckDB, and then it created all these resources for me. And then what I went ahead to do was create this file, simple pipeline.py, and then I have two examples here that I'm going to walk you through, or I have two functions that contains the examples I want to walk you through. So the first thing we're going to do is we're basically going to run this guy and then see how it pans out, or how DLT handles this. So we're running our pipeline right now, and then the pipeline runs successfully. We don't run into any issue. We can spin up the DuckDB UI we can copy the paths for our pipeline. We can come here and then we can add this guy, add the paths, and then we can call it Kafka Works. I mean, you can see that I've been playing with this, and here we have this user's JSON topic, right? And then if we query this in our notebook, we essentially get our data, and there should be how many records here? 25 rows returned, and yeah, estimated 25 rows, and those are basically our 25 rows. But then, I mean, the way the data is represented is not exactly maybe something that I like. I guess it's just in this field called _Kafka and then _data. And if you understand how normalization works in DLT, you know, it tries to flatten your payload. And so it's in the process of doing this flattening that it has represented the data this way, right? And so, I mean, first thing, it works. We have one topic, 25 records. So what we can go and do again is we can add, let's say, 30 more records. So if I just stop this guy, clear, I can basically run this again, and then, you know, let's add 30 more records just to confirm that this thing is working properly. And then if we add this 30 more records with 25, we have 55. The offset starts at 0, and so that's why it's 54 here. But then if we run our pipeline again, it should like take these new records in. Just gonna copy this path real quick, and then if we spin up DuckDB UI, let's kill this guy, let's delete this old cell, you know, let's do it all over again. Add the path Kafka Works, add the database, and if you check and we query it, we should have 55 records now, right? So it's working. We have data. We're doing it for one topic. Great, right? So what if we have a new topic? Because I mean that's a common scenario. You basically start out with your baseline requirements, and then, you know, as you work on a particular pipeline, you might need to support additional tables, additional topics, additional sources, right? So what if we have another topic? So let's introduce another topic, right? So we just had like a user topic. So now what we're going to do is let's introduce a product topic, right? So let's add products, right? And I'm just going to use the 20 that is here, right? Just going to do it this way. So we should essentially end up with a new topic here. So we have product JSON topic, user JSON topic, and then we want our pipeline to support these two topics, right? So what we can do is we can basically just copy this and introduce it here, right? And then we have two topics, and I mean there's 55 records, so let's add 45 more to our what's it called, our yeah, it was 55, so we want 45 to make it 100. So our user topic also, right? So I mean, just so like there's data in both topics, right? And so if we come here, right, we can see that we have this product topic with 20 records that we just introduced, and then this user JSON topic has 100 records now. So like we can run our pipeline again, right? And now our pipeline, we want our pipeline to track these two topics. So we've introduced the new topic, and then when you run this, you run into a weird error, right? So in like, it's not very easy to tell what's going on, but then you know that an exception was caused. And I mean, you can see that that exception is kind of like related to your product JSON topic. And so what we're going to do is, what if we just eliminate this guy, right? If I deleted this new stuff I introduced, right, and I ran this thing all over again, what's going to happen, right? So essentially, the pipeline is back up. It starts to work normally again, which, I mean, that was the first thing that I thought or I found weird in the way like this whole setup, you know, like was configured essentially, right? And so I mean, for some weird reason, right, like it works when you don't introduce a new topic, but then it breaks when you try to add a new topic. You know, that's kind of like the first thing that that I observed. The second thing is, what if we don't want to have our messages as JSON, right? Because right now they're JSON serialized. In like real world pipelines, for many reasons, you probably want to essentially ensure that your message is avro-serialized, for example, just so that you can basically preserve the schema, or like your type definitions in your source, and then like safely map those type definitions without inferring or guessing to type definitions in your destination system, right? And so like for all of those reasons, you may want to use a schema registry. You may want to use messages that are not JSON serialized, but let's say avro serialized, for example. And so like in that kind of scenario, what happens? Well, if we come back here, like part of the things I've done is I have created like a bunch of like avro schemas, which I'm going to basically register now. Right, and so like we have like user, avro, topic, product, order, payment, and return. Nothing strange. And then if you come to the schema registry, you can see all of these schemas, like, right, they've been registered. And so the next thing we're going to do is we're basically going to run our pipeline, and then we will run our pipeline to like try and read data using like vanilla DLT-kafka from a topic that has messages that are avro serialized instead of JSON serialized, and have a schema registry associated with them, right? And what we're going to do is the topic we're going to try and read is the user avro topic. That topic is here. Okay, we have to create it first. So I'm going to use the scenario command, which is just basically going to create a bunch of topics for us. Let's see, I think I have that scenario command somewhere. Okay, I can't find it right now, but what we can do is we can just run this, right, for like users, and then we're going to end up with like avro-serialized data. So if I run this, it should generate, yeah, user avro topic, which is basically what we have here. And then if I run our simple pipeline, we're going to basically start the extraction process, which is great, but then we'll run into another error. And basically it's saying that the Kafka consumer caused an exception. It couldn't decode the byte in position 5, invalid start byte, right? And so like there's some weird things. So two key things while trying out like the vanilla setup is, one, DLT seems to start with like a particular number of topics, right? Or allow you start with a particular number of topics, and doesn't really allow you go beyond those topics. So in your subsequent runs, after your first run, if you try to introduce a new topic, the pipeline doesn't work correctly. The second thing is, by out of the box, it supports messages that are JSON serialized, not necessarily avro serialized. And so also messages that are backed by schema registry, I think it's going to struggle with it. And so for these reasons, basically, I decided that, there has to be a way for me to kind of like get the right behavior out of DLT. There should be a way for me to extend it. And then I came up with like this document explaining like some of the issues that I'm unable to solve for out of the box with DLT-kafka, right? So it doesn't support regex topics out of the box, right? So if I have, let's say, 100 topics and they follow a particular regex pattern, which is common in CDC scenarios, you have a connector, maybe it's listening or monitoring tables in a particular schema, and so it's mapping all of those things to topics, and then they have, let's say, the same key prefix, for example, right? How do you use regex to track all of these things? And then another reason for regex is auto discovery, right? Because when you use like a regex pattern, if new tables get created and that translates to new topics in Kafka, you are able to automatically capture them without reconfiguring your pipeline. So I mean, there's benefit in real world scenarios where regex will come in handy, right? The vanilla implementation only supports JSON deserialization. It doesn't support avro. To the best of my knowledge, it also doesn't support like messages that are backed by schema registry. And then also, when you reconfigure your topics, when you add new topics to your list, it breaks, right? So you want dynamic topic handling, and then also like just some sweet, syntactic sugar on top of everything, like having like a CLI wrapper, have something that is like config driven, so that people can basically decide that they want to monitor a specific subset of topics, separately, and have it write to a particular destination of their choice in your data warehouse, right? And basically for self-service, and they can open a pull request, just follow a particular spec, and then that just turns into a full-blown pipeline, and it works out of the box. That would be like super cool, right? And yeah, extensible processors also. So they're kind of like a bunch of things I wanted to be able to achieve. And in my head, the vision is we're going to start from a YAML spec where you define, oh, this is how I want to authenticate. These are the topics I want to monitor. This is the destination I want it to go to. And then you can basically just configure all of these things as an end user. And when you submit that, basically there's like a CLI that can look at that config and just, spin up a pipeline and then use that pipeline to do your ingestion for you. And so that's kind of like the vision in my head. And source discovery is so important, because if you're working in a scenario where you have like 500 tables, 1,000 tables that you want to monitor in a CDC pipeline, for example, and then you want to go from that to like Kafka topics, you end up with about 1,000 Kafka topics. Regex is just great. And then addition of one topic doesn't mean you have to go and reconfigure everything again, right? So it can auto discover these new topics and auto create tables in your destination, right? And I mean, DLT can already auto create tables, which is like super cool. It can auto evolve your schema also, which is super cool. And that's kind of like some of the things I love about it. So if you are not very familiar with Kafka, I'm just going to try my best to explain some concepts high level. This is in no way like a perfect Kafka beginner crash course, right? But then essentially I'm going to try and explain some things high level, and then I'm going to explain how DLT has implemented like dlt-kafka source, and then I'm going to show you how you can easily extend it to get the kind of behaviors that at least I want from it, right? So essentially, right, Kafka is like a message bus. It's some sort of queue, right, where you put messages, and then those messages follow a particular sequence. So like ordering actually is a thing in Kafka, right? And usually you would have something called a producer, and the job of your producer is to write messages into a Kafka topic, right? And then you have something called a consumer, and the job of a consumer is to read messages off of the topic, right? Every single message that is produced is stored in a particular position in the topic, right? Like an index, if you're familiar with arrays in Python, right? Or if you're familiar with arrays basically in computer science, right? So like there's a position in the topic where the message is stored, and those positions are referred to as offsets, right? And sometimes your producer might be responsible for generating its own data, or it might be a more complex scenario where you have a system where you are monitoring changes in that system, and then it's the responsibility of your producer to have some sort of handshake with that system to collect new data and then write that data into a particular topic, right? That's the first thing. And then also the consumer basically reads the message off of the topic, and then it the consumer can do anything it wants with the message. Essentially, write the message into a sync system, right? Now, when the producer is generating messages and is writing it into Kafka, something called serialization happens, right? Because Kafka doesn't care about the content. Kafka just stores bytes, right? And your bytes can be JSON serialized, avro-serialized. I mean, you can use like protobuf to serialize it, anything basically, but what Kafka stores is bytes. And so before messages are written into Kafka, they have to go through this conversion process where they are converted from their raw or original form into something that Kafka can hold into a byte, and that process is called serialization. And when a consumer picks up messages from Kafka, the consumer has to be able to read the message, the bytes from Kafka, convert it into a form that the sync system, or whatever destination it's trying to send that message into understands, and that process is called deserialization, right? And so, certain key things to know is that it's based on your offset that you are able to tell, oh, these are all of the messages as a consumer that I've read before, and then if I'm coming back to my Kafka topic, this is where I can pick up from. So there has to be some sort of mechanism to track your progress as a consumer when you're picking up messages from Kafka, right? That's one thing. The second thing is there has to be some sort of mechanism that allows you to convert the message from bytes into a format that your destination can handle. So there has to be a mechanism for deserialization, right? And the way that DLT has implemented this is they have a class that is called your offset tracker, and the offset tracker is basically responsible for storing your information to enable you basically fetch data incrementally from Kafka and then track the progress of the system with respect to the offsets. So it can tell, oh, there are 10 offsets here, I've consumed 8 of them before, so I'm going to start at offset position 9, and then I'm going to consume the message on offset position 9 and offset position 10, and then I'm going to store that state information somewhere. So, I mean, it's able to do that. That's one. The second thing is it has something called the message processor, right? So the message processor enables DLT to take the raw Kafka bytes, convert them into messages that it understands, and then writes it into a destination. So by default, the default message processor assumes that the messages on your topics are JSON serialized messages, which is why when we try to read from a topic that was avro-serialized, we run into some sort of issue, right? So that's kind of like an assumption here. And then essentially, you basically need to tinker with your offset tracker. You need to modify it, extend it, if you want DLT to basically pick messages after the initial run. So if you want to add new topics after your initial run, you basically just need to extend the original offset tracker that comes shipped with DLT. That's one. The second thing is you need to write a new message processor, a message processor that can take the Kafka message, figure out that, oh, this Kafka message is not JSON serialized, it's avro-serialized, it's backed by a schema registry, and then, correctly deserialize that message and then hand it back to Kafka, to DLT, and then allow DLT to do its magic and write it into the destination. Those are some of the things that you need to do, right? That's one. Two, because I'm interested in like auto discovery also, I've basically added some implementations. All of the code is here. I mean, you can look at it by yourself. I'm not going to go over it here. But then if you want me to make another video where we deep dive into the actual code implementation, please let me know. I'll be more than happy to do that. But then essentially, I've also, introduced code to enable auto topic discovery, right? So I've introduced my own entry point where you can pass like a regex pattern, and then I can, basically figure out what that regex pattern is, find all the topics in Kafka that match that particular regex pattern, and then pass those list of topics to DLT so that it's able to do auto discovery. And then also, because I'm extending the offset tracker also that DLT uses to track offsets and manage incremental loads, I'm able to, recognize new topics and start ingesting them, see topics I've worked on before or consumed from before, and then continue from wherever I've stopped, and I mean, like, that's just really smooth. What else? So what I'm going to do now is I'm just going to create like a bunch of other topics before we proceed. So I'm going to check here and let's run a particular scenario. So let's run a scenario with 100 orders, 120 payments, and 50 returns out of the box. Let's do this, and then it's going to just basically create like a bunch of new topics. So you have like your order average topic, and then like some other topics too. So if we check here, while this is running, you can see now that we have like user average topic, and then you have order average topic, and then at some point it's going to create one more topic, which is the payment average topic. I think that should be like the last one. So you have all these new topics now, right? And then they exist, and if we look at the messages on this topic, we can see that I think I'm looking at the wrong topic here. If we look at the user average topic, we can see that this messages, like it's basically the same format, but then it's now backed by a subject in your schema registry, right? So, and this is important, right? I mean, if you are building CDC pipelines, I think it's really essential to consider using something like Avro to serialize your messages. If we look at this, for example, now, right, you can see that in the user JSON topic, there's 100 records and it's 45 kilobytes, right? That's the size of this particular topic. And then you can look at the user Avro topic. There are 25 records right now, and then it is 5 kilobytes, right? So what I'm going to do is I'm going to add more records to that particular user topic. Right, and then I'm going to add 75 records to it, just so we can compare them side by side and you see the point I'm trying to make. So I'm going to add 75 more records to this topic, and then you will see that essentially for the same 100 records, right, if we look at our user JSON topic, 100 records, 45 kilobytes. If we look at our Avro topic, 100 records, 23 kilobytes, right? So like when you avro-serialize your messages, they are smaller essentially, and they don't take up as much space as when you do it with JSON. And so, I mean, it makes sense that if you're moving a lot of data, you probably want to consider serializing your message as Avro instead of JSON, right? And so what we're going to do now is I'm going to show you how my extension of this entire thing works, right? The first thing we're going to do is we are going to look at this kafka.yaml file. I have a bunch of examples here. So you can see here that I have this particular spec where I'm basically providing like a name of my pipeline. I'm providing some configurations for Kafka. So I'm saying, oh, like, I mean, this is basically me hinting at the kind of authentication I want. So the vision here is to support simple authentication. So if you're just testing locally with like a Dockerized Kafka, you don't basically set up anything for authentication or authorization. You can use simple, and then you can also use MSK, but MSK is not implemented right now in this version of the code repository, right? But then essentially you can specify your consumer group ID also, and then you can specify the topic that you want to consume from, right? And so what we're going to do is I'm going to run this particular pipeline, right? I'm going to say Python, I'm going to say advanced usage, and then the resource here should match the name here, right? And then I'm going to run this. And then once I run it, it creates a particular pipeline for me, basic JSON example, DuckDB, which is this guy, and then I'm going to copy this path, and then I'm going to run DuckDB UI, kill this guy, do it later, let's delete this one, and if I add a path, and I call it Kafka Works, and I add my database, and we look at this, we can query this guy, which is the user topic, right? And then you can see now that the data is represented better, right? So that all of that nesting that you're seeing before, like I've extended the code, I've refactored it. I'm going to show you where that happens. So if you come in the base pipeline, and then you come in Kafka, and then you come in your helpers, by default, DLT basically passes that message under this Kafka key, which is why it was nested before. But then in the helper that I've designed, what I've done is, let's see, it will be in src lib helpers. Right, what I've done is I have created my own message processor, and then I'm exposing the I'm exposing my processed message, right, as a top level key also, right? So all of these things become like top level key value pairs. Like I said, I'll be happy to do another video where we go into the code and like just reverse engineer the whole thing together if you want. But then essentially you have it like this, and it's working. So now let's see what happens if I suddenly decide that I want to add a new topic, right? Let's see what happens if I say, oh, hey, I now want to track products also. So there's a product JSON topic here, right? There is a product JSON topic. It has 20 records. So what happens if I suddenly want, if I'm interested in tracking the product JSON topic? So if I clear this and I run my pipeline again, but this time I'm basically wanting to track the product JSON topic. You can see here, so it found the new topic, and then it worked gracefully out of the box. So if I do DuckDB UI again, just quickly copy this path and run this, and then let's just get rid of this. And let's come here to JSON sources, and then you can see like your product JSON here, and there are 20 rows, and if you query in current notebook, voila, you have the data here also. So I mean, we can see already that for like JSON serialized messages, like this extension that we have designed allows for self-service, allows for auto topic discovery, and then it allows for like automatically creating stuff in your destination for you once it discovers the new topic. So it's working the way we want. The next thing we're going to do is see how this thing works if we decide to use a regex pattern, right? So if we decide to use a regex pattern, I can delete this. So yeah, I mean, if you look at it and like you query, I mean, you have the data, it's working the way we want, which is great, right? So like next thing we're going to do is we're basically going to see what happens when we use a regex pattern. We have a bunch of topics here: the order Avro topic, payment Avro topic, return Avro topic, user Avro topic. So like, how do we use a regex pattern to support that kind of pipeline? So what we're going to do is we're going to come back here, we're going to kill this, clear, and then we are going to run our pipeline essentially for that particular resource, which is the basic Avro example that has a regex pattern, and then we're going to run it, and boom. So it should discover all of the topics that match that particular pattern. It should write it into a data set called dlt-kafka commas, and so if we do DuckDB UI, the pipeline should be basic Avro example DuckDB. So if we run this, copy paths, do later, put the paths here, still call it Kafka Works, add the database. We have dlt-kafka commas, and boom, it recognizes our topics. And then because of like how DLT does normalization, it creates some additional table because of like nested or normalized data, right? So I'm guessing that if we check the order Avro topic and we look at any of the messages, you can see that there's an array of product IDs, right? And basically when it normalizes, it will create like a sub table that associates orders to order product ID, which is why you essentially have like order Avro topic, and then you have order Avro, topic product IDs, right? And I mean, there are other things too. If you don't want the name of the table to be order Avro topic, I mean, you can basically adjust the code, and then you can essentially like tell the enhanced Kafka consumer how it should name the table, or how it should map a topic name to a table name, and like, I mean, that would work. So I mean, there's nothing set in stone that is saying, oh, like the topic has to end with like a topic prefix or whatever. It's just to kind of like drive the examples home, if that makes sense. And so we can also look at like our user Avro topic, querying the current notebook, and then I mean, everything just works like really well. I mean, this is really cool. The next example I want to do is I want to show you what this would look like if we're actually doing this against, let's say, something like kafka-connect and debezium. So let's say you have debezium listening to a particular table that has a particular table that has a particular schema and or a particular database that has a schema with like a number of tables in it, and then you basically want to monitor all of those tables. Like, what would it look like? Do you need to do anything extra? So the first thing I'm going to do is I'm just going to come in here and show you what I have. Then dt app.star, and I mean, you can see that we have app.customer. So the schema is app, you have customers, orders, and products. So there are 3 tables, right? And then I'm going to deploy a connector. And so I'm just going to make deploy connector. I'm going to deploy a connector, and then that connector should essentially create send a request to kafka-connect, and then when it sends that request to kafka-connect, if you come in here and you come to kafka-connect, and then you come here, we have a connector that is running, and then there should be like 3 tables that have your app prefix, right? So if we refresh here, yeah, you have debezium app customers, debezium app orders, and debezium app products, right? And so we basically want to track these things. And so what I have done here is I've introduced another example. I'm using a regex pattern also. I want to track these things, and then I want the target database to be DLT-CDC pipeline. So it's a CDC example. I'm going to come here, I'm going to run this, and then the resource is now going to be this guy, CDC example, and then it should run gracefully, hopefully. But yeah, it basically picks everything, and then when it's done, I can do DuckDB UI, and then I have my CDC example DuckDB here. I'm going to copy the path, and then we're going to run the UI. And when we come here and we add our database, and then we add Kafka Works, and then we add the database, we should see a data set called DLT-CDC pipeline, and then you can see debezium app customers, debezium app orders, and debezium app products. And then we can look at orders, we can query it in the current notebook, and boom, we have our CDC data, right? Which is super cool if you ask me. So like with this extension, I'm able to now go from like a vanilla setup to something that I can use in a production environment, and I can also design this thing in a way that I can enable other people within my team, right? So if someone in like the data science team wants to do experimentation, they can essentially just look in Kafka, see the topics that they are interested in, and then they can write it into a custom data set of their choice and start reading that data, right? And so all they have to do is open a pull request, add a new like config here, and once they add the config, it works, right? So once I approve it, obviously there's still like an orchestrator piece that should sit on all of these things, so that on a particular cadence, it can behind the scene run, it can behind the scene run a command like this, right? So it's going to run it, let's say every 10 minutes, every 5 minutes, depending on how you want to do your micro batch stuff. And it's basically just going to work out of the box, right? So what can you do to make this better? Well, there's room to also do the MSK stuff, and let me know if you want me to make a video showing you how to spin up MSK with something like Terraform, and then how to hook it up to your setup. Let me know if you want me to make a video where I essentially Dockerize this pipeline so it becomes like a Docker image that's version controlled also. And then you can basically anywhere Docker can run, you can run the Docker image, and it should work gracefully. And your destination doesn't have to be DuckDB; it can be anything else, right? And with this, you get all the advantages of a framework like DLT, right? So schema evolution. I'm going to make another video for CDC, and then I'm going to show you how DLT handles schema evolution gracefully, right? So you see how it handles schema evolution, which is super cool. And I've not even in using Kafka-connect and sync connectors, I've really not seen something that is able to gracefully handle schema evolution the way that DLT does. So I think it's a win-win kind of thing. I think this kind of example and this kind of extension is very useful in practice. So let me know what you think. Leave comments, ask questions. I'll be more than happy to answer them, and just basically do more stuff. And like I said, if you want me to walk through the code, my thought process, how I basically reversed engineered what DLT had and how I extended it to build something like this, please let me know. I'll be more than happy to make a video for that also. Until next time, I remain your humble data engineer, Emmanuel, and it's bye for now. Cheers.